All right, so let's consider the series here. Minus, as k goes from 1 to infinity, minus 1 to the k times 1 plus 8 over k to the k squared. Okay, so we could again try to look at this with the divergence test in mind first, looking at the limit of that stuff. But once again, I want to use the test that I have been using to check this out. So this having stuff raised to power k, k being my variable, leads me to want to kind of check out the root test. So we look at the series of the absolute value, right? We're testing first for absolute convergence. So this would be the sum as k goes from 1 to infinity of 1 plus 8 over k to the k squared power. Okay, so let's see what happens with the root test. Rho equals the kth root of 1 plus 8 over x to the k squared power. That will simplify down to 1 plus 8 over x to the k power, because kth root of that stuff to the k squared would leave us with just a k. That, of course, is a 1 to the infinity limit. A 1 to the infinity limit. So we apply ln to it, as we've done before. And when we do that, ln, the k would come out front. And we would have k ln of 1 plus 8 over x. 1 plus 8 over x. And that, of course, is an infinity times 0 limit. So we rewrite it as the ln, because that's the one we prefer to have on top. Ln of 1 plus 8 over x, all divided by the reciprocal of the other one, 1 over k. Okay. And then at this point, that transforms this into an infinity, or sorry, 0 over 0 limit. And so therefore we're able to apply L'Hopital's rule and take the derivative of that. So taking the derivative, we'd have limit as k goes to infinity. The derivative of that stuff, which would be 1 over that stuff, 1 over 1 plus, I don't know how I got x's in here. I do apologize. I think I misread my k here, and somehow my mind started thinking of x's. So let me quickly fix that. Somehow my mind started thinking in terms of x's there when I was looking at that for some reason. So those should still all be k's. So we're going to have 1 over 8 over k times the derivative of 1 plus 8 over k. That's 1 plus 8k to the minus 1. So that would be the same as minus 8 times k to the minus second. And that's all going to be over the derivative of 1 over k, which would just be minus k to the minus second. And then we do a little bit of housekeeping to clean this up. And we're going to have the limit as k approaches infinity. The limit as k approaches infinity. Limit as k approaches infinity. The k to the minus seconds are going to cancel out. The negative sign is going to cancel out. We're going to have the limit of 8 over 1 plus 8 over k. as k goes to infinity. Well, as k goes to infinity, 8 over k is going to go to 0. We're going to have 8 over 1. And so this is equal to 8. Now, remember what the root test does is we're looking at the original thing, right? But we had to transform that to ln so we could compute the limit. So now remember, rho is going to actually be approaching e to that power. And e to the 8th is really big, certainly bigger than 1. So therefore, by the root test, this is going to diverge. This is going to diverge. So it does not converge absolutely, at least. It may still converge conditionally in the alternating series vein, but it will not converge absolutely. One little note here with this problem. Part of the issue that this guy is facing is that because this is 1 plus 8 over k, this expression is always bigger than 1, and it's being raised to bigger and bigger powers. So that's kind of a problem there. It could keep getting bigger and bigger. If this had been 1 minus 8 over k, 1 minus 8 over k, then we'd actually been okay. 1 minus 8 over k, right, is always smaller than 1. And so everything would have carried through. You'd actually got a minus 8, and that would have been e to the minus 8, which is less than 1. And so if this had been 1 minus 8 over k to the k squared, then this actually would have passed the root test. This actually would have passed the root test, and we actually would have absolute convergence. Okay. But it doesn't, because it's equal to 8. So we do now turn to look at the alternating series. For the alternating series, I'm just going to initially look right at the limit of the underlying sequence. Limit as k goes to infinity of 1 plus 8 over k to the k squared power. I'm just going to look straight at that and see what I get. Well, once again, that's 1 to the infinity limit. So we apply ln. And we look at limit as k goes to infinity of k squared times the ln of that stuff, 1 plus 8 over k. 1 plus 8 over k. Okay, we then, again, as we've been doing, write it as log on top. That's going to be ln of 1 plus 8 over k divided by 1 over k squared. 1 over k squared. And now we apply our rule here. Limit as k goes to infinity. We apply L'Hopital's rule. So it's going to be 1 over 1 plus 8 over k times the derivative of 8 over k minus 8k to the minus second. Okay. All that over the derivative of 1 over k squared. That would be minus 2 k to the minus third. And so we continue carrying through here. That's going to simplify a lot. You're actually going to have minus 8 and minus 2 cancel. Make that a positive 4. The k to the minus second, k to the minus third would leave us with a k to the minus 1. Actually, a k to the first and top. So we're going to have limit as k goes to infinity of 4k on top over 1 plus 8 over k. right? And as k goes to infinity, 8 over k is going to go to 0. K is going to go to infinity. And of course, we then go back and say that the overall limit is going to be e to that power. Well, that's just infinity again. And so it's going to diverge. It's going to diverge because it doesn't go to 0, which is the first thing we absolutely need to have it do with the alternating series. So once again, our series diverges. Now, once again here, though, if we had been doing the series with the -1, what would have happened then? It has to converge, because I already mentioned again, if this had been a minus in here, this would have been a -8, and we'd have had e to the -8, which was definitely less than 1, and this would have converged absolutely. So what happens with the alternating series test? Since it converged absolutely, we wouldn't even have to do it, but if we did do it, it better still give us something that converges. And so here's what we see by the alternating series test. What we would see is if that was a minus, then all this stuff would have a minus here. And so this would actually go to minus infinity. And then e to the minus infinity is 0. E to the minus infinity is 0. So it still at least checks off that one section of the alternating series test. Then it will check off the other ones. So just that one little difference there makes a really big difference on whether or not this thing converges or, as is the case here, diverges.